does not give us the combination of transverse and longitudinal fluxes, but nets them into one. Okay, now the guy who wrote this book, Bewley, I was lucky to get this in high school, and this was my first exposure to the differential equations and the idea of non-electromagnetic waves, but he didn't get it worked out because he went from Steinmetz back to Maxwell and Heaviside, but nevertheless you get your first taste of the math. Okay, let's keep going. Keep going. So these are our various things we were talking about. Keep going. And this is his model of the inside of the transformer, which is not correct, but it starts to develop the theory. Keep going. So these are all the forces and all the geometrics and the dimensions of our thing. And we keep going. And it finally developed into our differential equation. Okay, so this differential equation tells us again, we have, in physics term, we have 4 dimensions of space. Okay, the problem is using the Maxwellian term, this term, centimeters cubed, or 1 centimeters to the -3rd, because it's in the denominator, keeps appearing in the equations. This is the missing element that splits the magnetic fields. And we'll get into this a little later. Let's keep going. So how would you like to solve that? I think my stuff's a little simpler, don't you? But this is how you start to really get the physics of the matter down. Okay, keep going. So these are just talk about it, but this is kind of, so now I've come up with this is basically, we're using the Alexanderson antenna Bolinas now as our model to develop the dimensions of this type of energy flow, because it had longitudinal as well as transverse wave propagation, which were phased in such a manner that there was no velocity of propagation whatsoever. It was infinite, or undefined. So the entire antenna, even though it was 3,000 feet long, the voltage was in the same phase at one end to the other, so the whole antenna would move in unison instead of Marconi's, where the energy had to go back and forth and didn't engage in the radio wave, but just had all this bouncy that caused, heavy voltages and currents that did nothing. Alexanderson eliminated the electromagnetic wave and kept the longitudinal because you wanted to transmit out into space, not from end to end of the antenna. Very significant invention, and the implications are stunning. Okay, keep going. We want to go to the math. Okay, so we're going to take this circuit representation as an analog computer to do calculations on. This circuit represents transverse electromagnetic power flow, where the lines of force are at right angles to the flow of power. This is the inductance of the space between the wires. This is the capacitance of the space between the wires. These are 2 wires like the ones we showed on the telephone pole. Okay, let's keep going. Now we have an inverse relationship. This is a longitudinal or a Tesla type of wave. This is like between the transform. We have the mutual magnetism between the 2 windings, primary and secondary, and the mutual capacity between the 2 windings. And now the energy is being carried where this way would be the electromagnetic. Go back to the previous one. Okay? See the same physical relationship. Okay, now go back to the next one. It's the same thing but turned 90 degrees. This is where the versor operators come in. These are the same coils and capacitors. This is an analog computer that I built. Charles saw these down in the desert. This is how I do my calculations with analog computers, because they're real. I can put a voltmeter on it and I can get shocked off of it. Okay, keep going. So now we're combining these things into what I call concatenated, where one network is compounded into another network of a different form, and we're taking the longitudinal and transverse and mixing them together. What's going off on us now?
It's
Flickering
conspiring.
a little bit.
The machine and the computer got together.
It's fine. Next.
Okay, let's keep going. Okay, now this one here represents the power flow in a Tesla coil. We call this a shunt concatenated transmission network. Okay, keep going. Now this represents the system of the Bolinas transmitting antenna, where part of that was compensated out by the opposite network. In other words, the transverse and longitudinal were phased with each other to cancel each other out. This is how the antenna in Bolinas was connected. Okay, keep going. So this is our test setup. Here's our experimental network, which consists of 10 of these circuit elements hooked in series to make a transmission line. or a transformer coil. Each one of these previous diagrams you saw was like one turn or one pair of wires, and then we connect them together to get our total line. So that's represented by this box, where Z represents the impedance and Y represents the admittance, which we went back to earlier, which is our basic ratios of magnetism to dielectricity. And the product of those two gives us our speed of propagation, or velocities, or time lag, or whatever differential function we're dealing with. In other words, what dimension are we changing? Are we changing in space, or are we changing in time? This gives us that factor. This gives us that gamma to the base and to the power that we saw earlier in the AC equations. Okay, let's keep going. Okay, now this is the response of the networks. Is there any way we can stop this thing from flashing at us? Or is it like everything else? Is it digitally out of control?
Pretty much.
So color wavelength type is out of phase.
So that's why I really encourage the complete dumping of all of this digital technology.
Like I said, the machine's comparing. That's the whole explanation right there.
They know you're analogic.
As I walk away.
He wants you there a lot.
It's what's called nano-nemesis. It's built into all digital technology. It's deliberate. It's a Trojan horse.
Try the laser pointer again, third time's the luck on that.
Well, I guess we have to live with it. Now, if you push any more buttons, it's over, George. It's tempting us to do that, okay? So let me play with this. We'll just cater for it. Okay? So we start to measure the bandwidths of these networks. We find that the normal transverse network, like a telephone line, okay, has what's called a low-pass condition. In other words, we increase the frequency, we get to a certain point where the line will no longer pass the frequencies. It will only go so far, and then it will cut off. But in a transformer or longitudinal type waves, it's the other way around. Okay, if the frequency is low, it cuts off. But as the frequency raises, then it comes up to the ability where it can operate. So we have two complementary types of waves. We have one which we call high pass, in other words, the highs are passed and the lows are cut. And we have one that's low pass, where the lows go through and the highs are cut. This is standard electronics technician terminology. Okay, let's go to the next one. Okay, now we find that these things generate harmonics, but now the harmonics are not simple multiples anymore, but are complex. These networks develop harmonics that are distorted so that we have a complex type of situation, more like musical chords rather than just simple harmonics. So this network here, none of these are in order, everything's all mixed up, which is just making it hell. This represents a complicated harmonic pattern of one of the networks. This one is the longitudinal network. So our harmonics basically are backwards in this case. Let's go to a forward one because I can't explain something without. Okay, this is our normal harmonic deal. Okay, so we have the fundamental, and then we have the next harmonic above that, and the next harmonic above that, which are progressively weaker and higher in frequency. This is a standard overtone series for any type of dynamics, like a guitar string or any of those type of things is explained in this harmonic situation. Okay, let's keep going. So go back. So let's go back. Go back. Go back. Now go back. Go back. Now on the longitudinal one, the harmonics are backwards. So instead of the third harmonic being 3 times the frequency, the third harmonic is 1/3 the frequency. Now this is something completely unprecedented in electrical network theory. It's a backwards harmonic slope. Okay, keep going forward again. So those are our 2 harmonics. So this basically then, now we're starting to, this is our bandpass flows. So let's just go beyond all this. I just wanted to show the 2 harmonics. Keep going. Okay, now this is the oscillatory discharge of these waves in a Tesla coil configuration, which is basically the frequency becomes slower as the energy exchange continues. Unlike the simple coil capacitor where we're locked into a certain frequency, now what happens is we have a chirp instead of a whistle. The frequency goes down as the energy goes down. These are the type of signals you find bouncing around inside the Earth if you have the antennas to pick them up. Okay, keep going. Now this is the Alexanderson network antenna in Bolinas on an analog basis. The energy readjustment is very complex here and fights itself. So it's much more difficult to tune these type of networks than it is to test on network, which tends to want to become more cyclic. So you can see the waves are fighting, but it's the same thing. The frequency is tending to go down. As we see, as we measure the time between the crests and troughs, they get progressively longer. Well, this was drawn off of an oscilloscope. Both of these were drawn off an oscilloscope. Okay, go ahead. So these are the bandpass characteristics of the various networks. So you can see we have frequency complications here. We don't have just like one frequency or harmonics. We have all these various frequency relationships like sidebands. And there's a certain type of bandpass condition here where the network becomes completely transparent or scalar, and that would be the point in which you would have no propagation velocity, but it would be uniform. But it's very difficult to achieve that balance, and it's kind of beyond the scope of the discussion now. Okay, now this is another spectral plot of one of these networks in oscillation. So you can see now the harmonics, and they will make these things very well suited for musical instruments because now you can produce these complex tones. Okay, keep going. I'm not ready for anything yet. Please don't disturb me. Okay, keep going. Keep going. Okay, so we're using this now as our most generalized network. This is our analog computer. This represents one element, or 1 centimeter of length down the Alexanderson antenna. Okay, keep going. So this gives us the capacitance, okay, in farads per centimeter, but now we have a longitudinal component, which is the inverse capacitance, or per farads per centimeter. Okay, now we have our normal inductance L, okay, which is in henries per centimeter down the line, but now we have a new dimensional relationship, which is the mutual induction, like between the transformer windings, in per henry per centimeter down the line. So now we have two inductions in the spatial relationship, and we have two inductions in a counterspatial relationship. We no longer have a simple double energy transient like the car coming to a stop and reversing. Now we can take a situation where not only the car moves forwards and backwards, but if you push down on it, the springs absorb the energy and push the car back up. So now we have the car bouncing this way, and we have the car bouncing this way. So now we have a complex energy interchange between 4 poles rather than 2 poles of energy coefficients, and it results in a mathematical situation that can't be calculated except by using the Steinmetz method. So let's keep going.
Can you pause just a second?
So what's that?
Hang on just a second.
You can try that laser pointer too.
I won't use any of this stuff. It's all man. I'm not going to just do all this with paper and a chalkboard.
Okay.
Then it doesn't send these ELF waves into your brain and try to make you get sick. Okay, so these are the standard dimensional representations that are used by electrical engineering. So capacitance is given farads per centimeter, is given in these dimensions. In other words, I have time squared in the numerator and I got length cubed in the denominator. So the capacitance in farads per centimeter is seconds squared per centimeter cubed. These are established by the British Association, and thereafter the dimensions that we call capacitance. Okay, it's inverse. Okay, where this is considered the compliance of the electric field. This is considered the elasticity of the electrical field, which is the inverse of capacitance, the mutual or the Tesla component. In this case, if I take it on a per centimeter basis, it gives me centimeters per second squared. So the distributed mutual capacitance, so to speak, is in centimeters per second squared. The transverse or electromagnetic is in seconds squared. It's basic, simple, and same thing with inductance. Henries per centimeter is centimeters. And the mutual inductance, if we remember we saw this in the Bewley equations, is 1 over centimeters cubed. This is the missing link. This is what took me 20 years to figure out. This is the missing link, and it's per centimeters cubed. Now let's turn these into space-time waves. Right now our topic is space-time. Okay, this is a little clearer representation here. Okay, keep going. So now we start to combine these things to develop our differential relationships, which is beyond our talk. Okay, this is kind of how they look. We can't get into this right now. Okay, keep going. We're arriving at something here. Okay, so now, go back. So this gives us two waves now. We take our standard electromagnetic wave, LC, which we've seen in the past in this presentation, okay? That gives us time squared divided by length squared per second squared per centimeter squared, which equals 1 over velocity squared, which is 1 over the speed of light squared. So the conjugate relationship, or the denial duality of these two fields, produces this velocity of light ratio. So whatever the velocity of light does in this place, this inductance and capacitance in the ether will sum up into that relationship and basically give us the inverse of velocity. We have the miles, we have, instead of miles per hour, we have hours per mile. We just turned it upside down because that's the way it works out. Okay, but now we have the Tesla component, the mutual inductance and the mutual capacity. Okay, now we have a velocity in counter space. So now the dimensions of length are connected to the dimensions of time as a product, which of course can't be. So basically, our length now is counter space. So what we have, where the speed of light was upside down, we're also upside down in this, but that's just the way that the equations work. You can't get around it. So now we have a wave that flows in space on a per centimeter, on a centimeter basis, and we have a wave that flows in counter space on a per centimeter basis. So these are our two waves. This is our electromagnetic wave, and this is our Tesla wave. And this is the dimensional expression of these. We call this a velocity and a counter velocity. And the sum of them two will annihilate the velocity and give you a situation that has space scalar and there's no variation, infinite velocity. Actually, the power companies use this. I don't have time to get into the detail. Let's keep going. Now we also have a different type of wave where this is the distribution of the two electrostatic fields. There's no time variation because their energies are the same type. So basically, it just varies on a per centimeter basis that goes down the line. It's a curve that just gets weaker and weaker and weaker, or stronger and stronger and stronger. And it's the same thing with the magnetic. So basically, if we abolish the Heaviside Maxwell concept completely and go to the J.J. Thomson concept, and Steinmetz came to a similar conclusion, there is no electromagnetic waves, and there aren't any of these other waves. What it is you have an electrostatic field propagating down the line, you have a magnetic field propagating down the line, and it's only the apparent superposition of them that gives you the velocity. That's why you can't see the stars or the sun in outer space, okay? Because the fields are not co-joined. The reason why the wire exists in the electrical system is so the magnetic field can exchange itself with the dielectric field. It's there strictly as a translational type of item. It's not there to conduct the electricity, it's there to translate the electricity. Okay, let's keep going. So then we have our Heaviside relationships and frequencies, and I think we've gone beyond all this now. If anybody's got the steam, we can go one more step or we can close it here, because the important mathematical concepts, but I have a more a readable explanation. But I think really we should cut it off at this point. So this is the point I wanted to get at.
Is the surface of the wire the interface to the ether, and that's actually what propagates this motion, these different forces? Is that what's going on?
Right. Maxwell's discovery was that the electricity flows in the insulators, not the conductors.
So a person could design a chip. Just hear me out for a second.
Well,
Hold on. A person could design a chip, theoretically, with an extremely high surface area to volume ratio, many layers of like nano-thin foils.
right.
To maximize this interface. Would that be a workable way to look at your model?
Well, the thing is, if you bring them close together, then you're storing more energy in the dielectric than you are the magnetic. But the ratio of the two always has to equal 1 over the speed of light squared if you're doing the transverse waves, so ultimately you might not accomplish anything.
Where I was going with this was to make a superconductive, or something that appears to be a ultraconductive item, that instead of being a wire or a square would be a bunch of foils in parallel, very
That would
thick
be
foils.
ultra-reflective. You say, when you say superconductor, that means it's a perfect obstructor. The electricity can't get through the metal in its transverse form.
Making a nanoscale perfect surface is no longer a manufacturing problem. It's
Right.
So that's why I was offering the flat.
Yeah. Well, if you form that into the shape of a transformer winding, where you have divisions in 2 axes, in other words, rather than one, you have divisions in 2 axes or 3 axes, then you can start to move these complex waves through the system. But that's basically, you're just building a transformer of very tiny dimensions.
Well, or you can build a replicatable structure on a larger scale.
Yeah.
And if you were to approach a manufacturer of this kind of thing that has this capacity, you might approach them with that idea. Well, you have a cat this kind of thing.
Yeah, that's kind of out of my area. Unfortunately, I didn't have time to get into the last part of this. It shows how I use this to receive these waves out of other dimensions, so to speak.
You just have to come back again
Yeah.
next month.
Well, I was trying to give you like a practical sense of like how like a big company might say, gee, we could use this for something. That might be really
Well, it's the power industry. The power industry already does this, okay? Here's the basic problem. This is where I'll close it because I got to take a break and drink some juice and maybe take a few more questions. Power industry has a problem, okay? LA Water and Power generates its electricity in Las Vegas because they don't care if they puke out the air in Las Vegas because Las Vegas is a place to puke. So what they do is they have this giant power line that carries it from Las Vegas to Los Angeles, which seems fine and dandy. The resistance of the line obviously is small, okay? But the problem is the power wants to flow at the speed of light, okay? Now, here's the condition that occurs. If the generators in Las Vegas are attempted to stay synchronous with the generators in Los Angeles, the problem is it takes a certain amount of time for the electromagnetic wave to propagate from Los Angeles, or from Las Vegas to Los Angeles. So now if the generator in Las Vegas is sitting at top dead center, so to speak, on one cylinder of an engine, or however you want to represent the phases, the one in Los Angeles has fallen behind by about 1/8 of a cycle. Okay, now if you get to the situation where the line is 1/4 wavelength long, a wavelength at 60 cycles is 2,880 miles. So it's kind of hard to do it, but there are some power lines that are very long. So here's what has to be done. If the line gets longer, the generator at the other end becomes more and more, it's in step with what it thinks happening because the retarded potential. When they become 90 degrees apart, they can no longer stay synchronized and you get a big blast. So here's what the power company
Unless
does.
you had quantum entanglement with the two
Well,
generators.
whatever, we don't, that doesn't exist in this talk. That's denied. Okay? So here's how they do it. They don't involve themselves in quantum mysticism because you can't make anything out of it that works in the electrical world. They use a very simple thing. They do what we were just talking about here. What they do is they take every 100 miles on the power line and put a capacitor in series with the power line. Now that capacitance in series with the power line sets the time angle back every time the wave is going through a capacitor station. These capacitors are gigantic. It would take 10 of these rooms to hold it. What this does is then it takes no time for the wave to go from Las Vegas to Los Angeles, and the two generators can stay in synchronism. What the power company done has made the propagation velocity through the Alexanderson and Tesla principles infinite. So there's no time delay of energy propagation. Now this is a practical example utilized by the utility companies to bring the two spatially separated items into one unit dimension in the dimension of time by neutralizing space. This is one way, this is how Tesla would transmit. He wouldn't transmit by transmitting the energy. He worked on the principle that the energy is brought into one by a mutual relationship where there is no velocity. In counter space, it's a counter velocity. The farther apart you are in counter space, the closer you are together. That's why these planets can have such a profound influence on the sun, which is going on right now. There's a big planetary alignment, and the sunspot number has been on the bottom now for, it's 22-year cycles at that zero dead point, and this will be the point in the next month which will start to rise and create all the usual havocs it does to the radio and power industry and the usual social insanities and all the things that go along with it. So I have to end there.
We're going to see the insanity part now.
What's that?
So we're witnessing the insanity part now, as a matter of fact.
Yeah, well, unfortunately, it's also cumulative.
We have a huge capacity.
There's a team in Korea that made that.
Oh my gosh. So that's the last tape, I would assume? Okay,
This here so we don't forget it.
okay.
Oh, man, that was a workout. Yeah.